You guys see the main
Yeah.
slide, right? Okay.
Yep.
Okay. All right. Hey everybody. Yeah. Thanks for having me. As Andrew said, I am I'm the founder of NYC.rb, among other things. So that was a long time ago. Yeah, I'm going to talk about OpenTelemetry for Rubyists today. Yeah, so a little bit about me. I've been a Ruby programmer since 2002, which is, yes, if you're curious, that's a pre-Rails year. I founded NYC.rb. I co-founded Gotham Ruby Conference. This was all a long time ago. These days, I am an independent software architect. I'm a process consultant. I've been getting pretty involved in OpenTelemetry, both contributing to OpenTelemetry Ruby, the open source project. I'm also, on my current engagement, I'm helping a large financial services firm implement OpenTelemetry within their apps. So that's kind of the experience from which I'm speaking. So yeah, OpenTelemetry. So you may have been hearing a little bit more about this in the past year or so. It's been rolling along for a couple of years, but the noise has kind of kicked up more. GitHub in May, which mostly is written in Ruby, had a whole big blog post talking about they're using it. In the Ruby space, there are also other companies that are pretty large that have been publicly using it. There's GitHub, there's Shopify, and Heroku. These are all Ruby-based companies that are using OpenTelemetry pretty extensively. If that news led you to go to the OpenTelemetry website and try to figure out what we're even talking about, you will probably see this, right? OpenTelemetry is a collection of tools, APIs, SDKs. You can use it to instrument, generate, collect, and export telemetry data, which is like kind of a lot, right? OpenTelemetry can be, for a lot of people, pretty complicated and pretty intimidating if they do not already have a lot of experience in the space. So that's kind of who my talk is for today. Answering questions like, what problems does OpenTelemetry even solve? Does it have to be so complicated? And is it relevant to the place where I work? So to start, we'll start with a single app tracing use case. I'm going to be talking mostly about tracing. The metric stuff comes in a little later, but tracing tracing an application when it's running in production is a concept that's been around for a long time. There's a lot of different APM is often the term that gets used here, but basically the idea is that you want to trace the behavior of an individual transaction as it kind of works in sort of subcomponents of what has to happen in software. This screenshot is from Elastic. They have an open source APM product, but there's lots of APM products that do this. New Relic's one that a lot of people know, Sentry, etc. There's a ton of them. Right. This is this is an Elastic APM sample screenshot, as you can see sort of down below, what you're calling questions controller index. And you have this sort of tree structure where you sort of subdivide the call into lots of individual steps, which is going to be helpful for performance profiling, could also be helpful for debugging if something breaks somewhere along the way. This whole tree structure at the bottom is called a trace in sort of the parlance that we're talking about. The individual pieces are spans. So a trace is a tree structure composed of one or more spans. It has a root, it has a bunch of children. If you imagine conceptually what it looks like to profile this, if you've ever looked into like the APM, library you're installing in your Rails app, it's like not that hard to imagine, right? You have some piece of code that you load when you load your Rails app. It's listing in on a bunch of different sort of like behaviors, controller calls, maybe active record calls, and it sort of like sends them out to some backend. In this illustration, we're talking about Elastic APM. But what about multiple apps, right? Increasingly, most of us work in technical infrastructures that are not single repo apps, right? The sort of the monoliths are getting harder and harder to sort of justify. Though there's a lot of benefits to the simplicity of the monolith, but of course, a lot of organizations reach that tipping point where they want to start distributing things out. And what ends up happening is that the sort of single app tracing use case doesn't work very well. You actually want to track a trace across different repos, like service A calls service B, right? So now you have this thing called distributed tracing. Here's another screenshot. This is also Elastic APM, and you can imagine it's got a dashboard trace. It starts in one API, one service app basically, and then a couple steps down, it calls API REST top products, which is now a call inside of a second API, right? We all know, of course, like Amazon, the Amazon website, famously, every time you load up Amazon.com, it calls like 100 services and they all get sort of stitched together. This is sort of the piece that gives you visibility into what's calling what. And it's actually taking data across multiple different code bases and kind of pulling it all together into one trace. Now, if you imagine what this looks like conceptually, you've got app 1, you've got app 2. App 1 is calling app 2, and they both have an agent that is both collecting spans and then sending them out to some backend. And the backend has to sort of collect it all and says, oh, this is all part of the same trace. Once you start doing this, there's a ton of complexity that starts showing up, right? A lot of new requirements show up. You have to be able to propagate traces between services. So when app 1 calls app 2, it needs a good mechanism to say, here's my trace ID if you want to do something with it. Both app 1 and app 2 need to export their format to a backing store, and you probably want some kind of standardized format. You probably want some standardized sort of network protocols. You want this to be language independent because, as is often the case, these apps are not always written in the same code base, right? You might have one Ruby and Rails app that's calling a Go app or a Rust app or whatever, right? You want it to be vendor independent, often because what's happening here is you start generating a ton of data and the bill can be pretty high. And so you don't want to spend a ton of time instrumenting every app in your whole organization and then find out after 6 months that you cannot switch to a vendor where you get better performance or better pricing. And you don't want to hurt performance or add bugs, right? You're adding a bunch of code into your running applications, right? There's certainly no virtue in monitoring performance if you're going to make it much worse in the process. There's certainly no virtue in actually creating new bugs if you didn't have them before. So that's kind of what OpenTelemetry is for. It is a framework for sort of standardizing a lot of these best practices, and it kind of works at the beginning of this trace generation. It's for instrumenting, collecting, and exporting this data. So how do you put it into a Rails app or a Node app or a Java app? How do you collect it? How do you send it out? It's worth noting that OpenTelemetry is not standardized what the backend is. So there is no single OpenTelemetry way to visualize traces, and it works with a bunch of vendors. It works with a bunch of open source things. So OpenTelemetry can be used to send stuff to Elastic APM or a bunch of other places, which gives you the vendor independence. Everything OpenTelemetry does is open source. It is vendor agnostic, by which it's actually sort of a standardized interface that interfaces with a bunch of downstream vendors, and it's language agnostic. So it's a very big kind of like open source project. It's got a lot of different working groups and a ton of process. It's the biggest one that I've been involved in ever in terms of, and it feels a little, it's not like you and 3 friends coming up with some cool Rails gem that you think other people might like. It's like a whole giant thing that's progress is measured in months and quarters. And even the word framework itself is a little tricky, right? When you call Rails a framework, Rails is actually a piece of code that you can install with a command, right? But OpenTelemetry framework is mostly concepts. So there's a common terminology, like this is what we mean when we say trace, this is a span, this is a resource, this is an attribute, blah, blah, blah. There's a lot of like recommendations about performance and error handling, protocols, infrastructure, right? A library that calls itself an OpenTelemetry client library cannot create new errors, these kinds of guarantees, but it's all sort of written down in a spec doc. It's not code really. And there's standardized names for classes and methods, which is a little weird because sometimes, especially when you're a Rubyist, you're used to like Rubyists are kind of like snotty about like having really elegant like method signatures, right? And stuff like that. We really like that kind of polish. And you kind of don't have that here because you have to use, you're kind of required to use the same method names as like the whole project defines in the spec. So it's a little weird, right? Because you're like, well, why am I letting some Java programmer tell me what I should call this method? But that is just sort of part and parcel, and I'll talk about why that's actually worth the trade-off. There are also open source libraries, but there isn't any one open source library. So there's language-specific client libraries, OpenTelemetry Ruby, which is the one I've contributed to. There's one in Java, there's one in Node, Go, Rust, Swift. There are instrumentations, which I will talk about later, but that's basically like sort of pre-packaged ways to hook into commonly used libraries in your application to instrument the things that you typically do with them. And there's something called a collector, which is an optional way an optional sort of, it's a binary written in Go that you can ship and sort of take all the data. So it kind of gives you a good like resilience if you're sending a lot of data down a pipeline and you don't want to worry about like what might break along the way. Anyway, so that's a lot of concepts. But let me take us back to a specific code example, and we'll start with something really simple, right? So you've got a Rails app, it's got products, right? Some really bog standard e-commerce app. And you've got a show endpoint where you just get a product out of the database and you render it in JSON, right? You can basically set up OpenTelemetry really quickly at home on your laptop by running Jaeger, which is another open source tracing solution, and it works out of the box with OpenTelemetry. So that's actually the Docker command, right? You can Google that and find that, but you could set that up, download it, and have it running on your laptop. And then if you go back to your Rails app, you want to create like your OpenTelemetry configuration, your initializer, right? This first line, OTel traces exporter, basically tells OpenTelemetry, I'm exporting to Jaeger, so send it in the Jaeger format. And then you sort of configure the OpenTelemetry SDK. You're instrumenting for Rails and you're instrumenting for active record. So that is those instrumentations I talked about before. And then the service name you're required to set because that's actually what your application is going to call itself to the entire sort of distributed tracing infrastructure. And if you hit the endpoint, what you'll see in Jaeger is basically this. Now, this is a really simple single app trace, right? But you can sort of see that a configured Rails application will kind of collect traces. It does this automatically. It knows what controller methods are. It knows what active record methods are. It kind of makes a span for each and sends them out. You can imagine what this looks like, right? There's inside of your products Rails application, you've got a built-in instrumentation for, it's actually rack, and then there's one built-in for active record. That little telescope is the OpenTelemetry logo. They're all going to this thing called the exporter, which is inside of your Ruby process in your Rails app, and then it will sort of send out to Jaeger. The exporter has a lot of options. Usually when you're doing development, you will export, every span one at a time, so you get fast feedback. When you push it out to production, you usually want it to be some kind of batching exporter that sends at most every 5 to 10 seconds, or whatever. There's a bunch of batch configurations in it. Anyway, the instrumentations are a big part of the power here, right? Every language implementation packages a bunch of instrumentations in it. They usually write them for the library maintainers, and this is what exists right now in Ruby. So if you were to run a Rails app with Sidekick, and then occasionally you're calling other services with Faraday, you have like a ton of like automatic instrumentations. It sort of knows the kind of things you typically do in Sidekick, and it creates a span at certain things. This is sort of built-in defaults that you can sort of extend on your own. Okay, so that's the single app case. That's pretty boring. But the second part is when you kind of have a second Rails app. So let's say there's an inventory service and it's separate, right? And it's and you call it and you get JSON and you just merge in the inventory with your product, right? And now you're in this is the products app. I've added the Faraday instrumentation. That's the only thing that's different here, right? Faraday being the pretty common HTTP client used in Ruby. It's usually the one I reach for. And then on the inventory app, let's say you're just literally creating a random stock on hand. So you have 0 to 99 stock at any time, completely random. It's a kind of a buggy app. And then you're gonna configure OpenTelemetry in this inventory app as well. This looks the same as before. Notice that the service name is inventory instead of products. And this is what this is going to look like inside of Jaeger, right? You'll create the products, you'll hit up the products endpoint, it will ask inventory what it's got, and both of them will sort of generate their spans and send them out. And Jaeger, and really any backend that can handle this data, is going to stitch it all together in a tree. So you know that end to end, you're talking about 228 milliseconds. Here's what parts took what time, in what order. Conceptually speaking, what's happening, right, is you've got sort of the different libraries, and you've got the products app calling the inventory app, and they all sort of in their own time collect their spans and send them out to Jaeger, which then assembles them. There are a bunch of other features. You can do manual instrumentation. So what I've been showing before was like just automatic instrumentation. You literally just have to install some things in an initializer and you're good to go. You don't have to change any application code. But if you have specific chunks of your Ruby code that you want to like measure, then you can do things like this. You can just call the tracer provider and date in span and call another service, right? And what will happen is it will actually create another span. This is at the very bottom of this trace. And it sort of stitches it all together for you. Now, one thing that's worth noting, and this is part of what makes the design pretty convenient, if we go back one slide, there is no, when you create all this stuff, there's no reference to finding your parent span. There's no reference to even knowing if you're inside of a trace, whoever created whatever, right? That's intentional, right? The whole point is that like, if you're as an individual developer, you don't want to have to like think really hard about where all this stuff is coming from. OpenTelemetry is just going to sort of do it for you under the hood. And when the data all ends up in place, it's all stitched together with the right sort of parent-child relationships. There's a bunch of other features. You can attach attributes to these spans. So you can say like, oh, this is, you can say this is the library we're using, this is the version we're using. And they're arbitrary. There's also a recommended set of conventions. They're pretty optional, but it's like there's a lot, so it's kind of like easier sometimes. You're like, well, what did they say I should do? I'll just use those. There's sampling. Some teams, the financial services company I'm working for is not doing any sampling, so they record absolutely everything is the goal. But if you're like a social media site, you probably don't want to, because this generates a lot of data, and data isn't free at the scale. So there's a bunch of different ways to sample. So like, oh, we only record 1 out of 1,000 traces, or we want to record 1 out of 1,000 of these traces, and these traces we want to record more often. Then the exporters, like I said before, there's a bunch of different configurations. You can say like, oh, I want to batch it to these profiles, use a little more memory, whatever, things like that. And then there is the OpenTelemetry collector. The OpenTelemetry, again, to refresh, the OpenTelemetry collector is optional. It sits between your applications that are generating the OpenTelemetry data and wherever you're ultimately going to send it. But it's good. It kind of can give you good performance and sort of resilience. If this whole system gets backed up, the collector is sort of responsible for sort of buffering that. So it'll take a little longer for you to get your telemetry data, but you will get it, as opposed to just like everything falling apart and losing data. So that's kind of like the main use case of OpenTelemetry is distributed tracing. And this I've just kind of like thrown a bunch of stuff at you guys. It's sort of a lot. It's useful. It's worthwhile to ask, like, is this worth it? This seems like a lot. What we get out of it. The downsides are pretty meaningful, right? It's complicated. It's worth noting that it is under active development. The tracing spec is pretty solidified, but there's a bunch of other parts of the spec that are sort of catching up. Different libraries are sort of at different degrees of sort of solidity, and the documentation is still in progress. Because quite frankly, there's just like a lot of surface area. And so you'll find parts where some document that was written, it happens to me all the time. You'll Google something, and then the best thing you can find is a document that was written 6 months ago, but it turns out the interface has changed, or the method names changed in some subtle ways. So from time to time, you'll be picking through that. That's like not free. And you need to decide a backing store, right? There's a real vendor selection process here. The good thing is you have a lot of vendors to choose from, both commercial, like hosted, and also open source. But of course, that's not like something you do automatically, and hosting open source with the large amount of data, also definitely not free. So those are the downsides. The upsides are pretty compelling to certain kinds of organizations. You can diagnose bugs that would be impossible otherwise. The client I'm working with is a large company, and they have a lot of services calling other services, and they instrumented they're instrumenting their front end, and they're kind of working backwards deeper into their infrastructure. And within like a couple of weeks, they were able to realize that they were calling through other calls, they were calling a service literally like 50 times more than they should be calling it, right? So they kind of, which give them the impetus to increase, there's a architectural migration, so they were migrating it to a newer hosting model, but also just like, let's stop and think like, how can we optimize this? Because it's so massively wasteful. It's the kind of thing that like only was actually impossible to see without this kind of visibility. The community is quite friendly. I think that like it would be a mistake to read the documentation and think, oh, this stuff is hard because these people don't care about spreading the word. My experience in the Slack, there's a Slack on CNCF, people are very active. My experience is people are super helpful. It is mostly, the vast majority of people in this community, from what I can tell, come from the SRE side. They've been working really hard on just making sure like it doesn't break anything. They know it's complicated for app people, and so they're very eager to sort of spread the word. So if you show up and you sort of ask politely, usually the person who is one of the core contributors gets back to you in a day and says, "Have you looked at this? Can you try this? That's an issue." Blah blah blah. So there is lots of free instrumentation. Like I said, like even you could hook the stuff I showed, in the demo app, the demo code before. You could probably hook up your own duct tape version of that, not that much work, but you'd have to like write hooks into like action controller. You'd have to write hooks into Faraday and active record. And then if you want to do sidekick, you get, so these hooks are kind of already there and people are using them in production. And there's a lot of community momentum. A lot of this stuff is now getting rolling. Like we said, a lot of companies are getting on board. And for distributed tracing, OpenTelemetry is becoming the standard. I feel pretty, as somebody who is like a decent sort of like history looking at technology trends, I feel pretty good about this one. The languages in beta are pretty long. Like most major languages now have like application in beta. And beta, by the way, means GitHub's using it. So like beta is not super risky, right? There's a lot of vendors that support it on their end, AWS, Elastic, Honeycomb, blah, 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 right? So they'll have a whole page like, here's how to use if you've instrumented your apps for OpenTelemetry, here's how to use it to get your data into Elastic or Honeycomb or Sumo Logic. And I think like, I could go into the details of like why this is the version that's working. Some of them are sort of arcane. There's been a couple of rounds of this. There used to be 2 different projects that got merged I guess a year and a half ago, 2 years ago. And now it's kind of rolling downhill. And the analogy that comes to my mind now is that OpenTelemetry is to observability as USB is to hardware connectivity. I'll explain this. If that makes you like wince a little, that's like understandable, right? Like USB is really kind of messy, right? There's like a ton of weird USB connectors. I don't know about you. I have like a box in my closet that's like all these USB cables, and sometimes you take them out like, why do I have this? Like, when did I even have one of these, right? But so it's messy. But what ended up happening over time is somehow, I don't know the details of USB, but somehow they sort of found these like common efficiencies along the way that made USB sort of cheap and ubiquitous. And now we're at this point where I have a cat fountain that is powered by USB. Like a water fountain for my cats is powered by USB. And anytime you get into an airplane, they have USB chargers in the back of the seat in front of you, right? Which means if I wanted to, I could take my cat fountain and I could charge it in the plane, which is a terrible idea, but the pipes are already there, right? That's like a sign of how completely ubiquitous USB is. You don't even think about that now. I think OpenTelemetry is a similar kind of problem. Observability is a coordination problem. To get all this stuff to work together, right, you have to get a Node team and a Java team and a Ruby team to use some similar set of protocols and practices and language, right? You have to support every major language. You have to support every major vendor. You have to support every major like library you want to instrument. And so completeness is actually a lot more important than elegance. I can absolutely look at the spec and look at some pieces and be like, well, I don't know how, I can think of like criticisms or like things that I think are like maybe not the most elegant way to do it. But I think like, the OpenTelemetry got to a sort of a place of being 80%, 90% complete and being a little messy. And everyone's like, okay, now we're piling on. We're making this real now. Yeah, so I think, for this problem, and for this solution, OpenTelemetry is it. Whether or not you need that today is a question for you to ask yourself. But if you do, if you're interested in it, you want to think about how should we get started. There is no, this is not a small process. An OpenTelemetry rollout is one of the things I realized the more I was in this space is that is the way some people use the word journey in like software or really large organizations, which journey just means we're doing this thing and it's taking forever. That's really what I realized it means. Like, oh, we have this initiative, it's going to take like 18 months or whatever. It's not a month of a lot of coding. It's like a bunch of teams like rolling forward. This can be, depending on the size of your organization, whatever, it can be kind of large. You should plan for a learning curve. You should be budgeting for in-house implementation expertise, which is to say that you can hire a consultant, but you can also learn yourself. But it's not, someone's going to have to sort of like spearhead, like getting their head in the space and really understanding a lot of the details. You're going to want to be getting involved with the community. The odds are you absolutely need to be getting on the Slack, right, and being prepared to like ask questions. The odds that you're going to want to submit PRs are not that low. Of course, for a lot of us that's kind of fun, but it's definitely like, you might find little gaps. It won't be that hard. You're also going to want to formalize team training and backend tools. So this is not an OpenTelemetry thing as much as sort of a observability and ops thing, right? But like these enable very sophisticated tools, but sophisticated tools are no good if people don't use them, right? So you're not going to really, whatever you do isn't going to have staying power unless you actually sort of like keep winning converts. Like, oh, we got this one team, we trained them how to use this thing, and then a week later they needed it. Now half of the people on the team are like, this thing's amazing. I'm really glad we did this. And you should be planning a long-term vision with short-term releases. Luckily, a lot of the way OpenTelemetry is designed is that doesn't make it that painless to do this incrementally. It doesn't make it that painful to do it incrementally. So automated instrumentation first, manual instrumentation later. So what I've seen is that a lot of teams get a lot of value by just installing the default thing, right? Like you can absolutely in your app think of some one time this one service class is doing this one thing and you don't know, and you need to really do a lot of custom spans and stuff. But honestly, like just getting it set up and getting the data and being able to see your controller methods being called, your active record calls, your sidekick calls, like that's going to be like a huge amount of value right there. And that's just configuration. The other thing is user-facing services first and backend services later. So one of the things I didn't talk about before is that traces can actually be incomplete, by which I mean, if you have your sort of your front-facing API and it calls a bunch of APIs behind it, it passes the OpenTelemetry data with its calls, but it's totally optional, right? It's basically, and if it's on HTTP, for example, they're just headers, right? So what you're saying to this downstream service is you're saying, I don't know if you even speak OpenTelemetry. If you do, here's what you need. If you don't, that's cool. We're just going to do whatever we need to do to have the application logic fire. So what I've been seeing is you sort of start with the app that is like where the trace originates, right? It's usually the first thing that our users hit, right? And then you'll see the outside of like, oh, I called this service. This service isn't instrumented, but you still get a lot of value there. So yeah, those are some ideas and tips. That's kind of my prepared section, but I bet you guys have questions, or I hope you do, because I've thrown a lot at you. Please, who wants to ask me a question? Yes, sir, Dimitri.
So Francis, first of all, thank you for this, and thank you for the overview. I'm super kind of excited about it. Specifically, I worked with SRE teams a lot in the past, and have you had a chance to, at like big client or big company scale, compare this to the tools that New Relic, for example, offers out of the box, or one of the like larger kind of like, performance metric, folks who are like, here, we'll just do everything for you, compared to this, where I think you have like a bit of a lift on your side, but then you have your data and you can use it however you want to?
Yeah, I think that like there's definitely a lot of overlap in the sort of conceptually in the technology. One of the things that OpenTelemetry moves us off of is this idea that there are vendor-specific agents that you install, right? It used to be you sign up. It used to be you sign up. You have a Ruby on Rails app. You sign up for New Relic, and New Relic says go to download this New Relic Ruby gem that you run and you configure with your API key, right?
Context, like the New Relic bill at the organization where I worked was over $100,000 a year, like kind of significantly over.
Yeah.
And it was really, really hard to push that down. Like,
no, it is. I mean, I don't have strong opinions about New Relic's sort of quality at that scale, but it's definitely part of the thing, right? Like these bills, it's a ton of data. It's very expensive to deal with it if you're not careful. And and if you set up an OpenTelemetry implementation, then what you can do is you can sort of compare, right? And now you're like, okay, actually we can talk to 3 different vendors, right? Typically, if you've already got New Relic set up inside of an infrastructure, just if you stay on New Relic, you're probably not going to go to the trouble of like switching to OpenTelemetry because it's kind of the same data more or less. right? Usually it's bound up with like the vendor, the client I'm working with, they're switching vendors in the process of this. And they're like, well, as long as we have to instrument to a new thing, we might as well do it with OpenTelemetry. And then, a year down the line, we might change our mind about the vendors and we can just sort of point our pipe into a different place. Yeah. Does that answer your question?
It sort of does, I guess, like in your experience, or at least in what you're seeing now with this, kind of, again, it's a big effort, I understand, but are you seeing that, or like some glimpses of that becoming true? Just because like that being true, meaning like that, going to use a different vendor is actually it's a real scenario, or like it's possible. In other words, like, are you experiencing like on-vendor lock-in and the actual promise of the ecosystem?
I guess I can't say that I have, in the sense of like, I think really what some people would want to hear is this idea of like, are we already on OpenTelemetry? We had OpenTelemetry with vendor A, and now we're going to take our OpenTelemetry and switch to vendor B.
Right.
Yeah. And I think that sort of remains to be seen, or really all this kind of common interface stuff. I also think that like, it's not that like, the idea of these services being backed by like SaaS services is actually pretty recent, because I think like the sort of the macro story is like a lot of the distributed tracing like 5 years ago or 10 years ago was written at companies like Google or Uber or Amazon, and they rolled their own, right? And the idea that another company would do that for you seemed like there was once a time when people were like, well, there's only 10 companies in the world that need this, so I'm not making a business off of that, right? They're going to do it themselves, and then we're done. But of course, now we've had this new emergence. Honeycomb is kind of the one that always comes to mind, but there's a sort of this newer wave of observability startups that were built with this in mind. And then OpenTelemetry is kind of their way in the door. But yeah, I don't know that there's been a lot of hops off of one to the other yet. Other questions, thoughts? Does anyone have anything?
Kind of like pipe your experience some more, meaning like get some more experience from you. If somebody has an application and it's like, 2 APIs and a front end type of a thing, so like fairly minimal, what does the onboarding look like?
If I were to do like the minimum viable, yeah, the onboarding is kind of what I just showed in the code samples, I guess. I mean, you'd have to choose that. What the cheat in the code samples is I'm running Jaeger on my laptop, which is not, or I think that like, if I was running the minimum viable, then with like a semi-product, like a staging or production level,
yeah,
of like, I'd probably look into something really cheap, right? I think that like, so by the way, Amazon AWS has one called X-Ray. I can't speak for the quality of it relative to other ones. I believe both Honeycomb and Lightstep, they have like free tiers. Another thing worth noting is that with sampling, you can set your sampling way down. So you can say like, I only want to get 1 out of 1,000 traces. And a lot of the observability systems, they charge just by data, right?
yeah.
So if you send them almost nothing, you can almost like get in, like kind of stay in the free tier if you sort of want to help people visualize that. Obviously, like at that lower scale, there's certain kinds of like tools and stuff that like, there's certain kind of like features that aren't not going to be apparent if you're not like running a lot of data through it, like aggregated trends and like real-time learns and stuff. But that's an option as well. It's also worth noting that these companies all kind of have sales teams, so like, right, like you can kind of make them walk you through that too. But yeah, the actual like app configuration stuff for an organization that has like pretty up-to-date, like has a small-ish infrastructure, the microservice setup, and a pretty up-to-date code base, I don't think the setup's that hard.
Cool.
Other questions, thoughts? Is there anyone who thinks their organization might benefit from this approach, or definitely wouldn't, or Is that something that people are thinking through? I also looked up, and unfortunately, I don't think there's a Perl version of OpenTelemetry. So I don't know.
Don't worry, I'll live for now.
Sorry?
I said I'll live for now. I've got so much on my plate. I'm basically spinning up a microservices framework, and the telemetry might even be out of my hands. So I'm just more here just to absorb the general approach.
Yeah. Incidentally, depending on sort of how that stuff gets sort of sent out, like a lot of what's built is there's a couple of different ways to put this inside of like an application, right? Like the Ruby approach tends to be sort of like you load the agent inside of the Ruby process, but then like I've seen like Java has a mechanism. It's like an AOP style mechanism that's built into the JVM. They've used it for years, but I think also people are using this as sidecars. So people who are doing like Kubernetes service mesh stuff. Some of the activity you can intercept from the outside, especially network traffic and stuff.
Yeah, I mean, my experience with it previously was exposure with things like StatsD and Prometheus, but I'm not even sure how much crossover there is with what you're doing. So.
Yeah, I think that like this tends to be much more. OpenTelemetry is actually extending into, so they say like, observability has there's the three pillars of observability, right? Metrics, logs, and traces. That's kind of like a thing you hear a lot. But honestly, like if you ask me, traces are the ones that are really developed. Metrics and logs are being sort of like folded in, and probably we'll get there a little later. But sort of the distributed trace is kind of the thing that's really like super valuable right now, I think. And so then like StatsD, which is typically used to like emit metrics, for example, right? Like if that was the key thing, maybe you don't do OpenTelemetry quite yet.
Yeah, well, it's good to be aware of it. And thanks for the insights.
Other questions, thoughts?
It's Craig Strong here.
Hey.
I've been I attended a Ruby conference some years ago, and one of my clients said, "Hey, I want you to write something in Ruby on Rails." I said, well, I better learn it. But I had done Groovy on Rails years before, so it was so nice to do it. But anyway, we're bidding on work. We're in the top 3. We may win, we may not, but it's with a federal agency, and they're 100% Ruby on Rails. So I'm really excited. I hope we get in there. It's the U.S. Citizenship and Immigration Service. And I believe, and they have hundreds and hundreds of applications, and they're all connected and everything else. So I think OpenTelemetry would be a huge win for them. And their side of the agency is 100% Ruby on Rails. All the rest of the agency is 100% Java. So the interoperability aspect is huge as well. So.
You mean their services calling each other across Ruby to Java and vice versa? Yeah.
Yep.
Yeah. I mean, I think like, yeah, I mean, I think that makes perfect sense. I mean, if you have questions later, you should hit me up. But one of the things that I think is like, that I keep coming back to, and this is part of the reason I got into this event, like originally when I started digging into it, is that like, we spend a lot of time trying to understand the behavior of our code, and we often do so by simulation, like writing automated tests is simulation, right? Or here's what we expect this controller action to look like, or here's what we expect a user is gonna click through in a browser, and I'm gonna use Selenium to do that, right? But in fact, like as systems gets bigger and more complex, the ability to sort of simulate ahead of time like degrades, right? And the gap of like, oh, here are the things that you didn't test for because you could not imagine them. These things could just continue to grow. Like a lot of the sort of the simulation as testing is really just this idea of like, I can understand my code at rest. If I'm just smart enough, if I just work hard enough, I just refactor enough. But in fact, in my experience, it's like you can be a really good programmer who means really well, and stuff's gonna slip, and it's harder when the teams get bigger and the cross-language stuff, and who knows, whatever, maybe that one person who wrote that thing is on vacation for a month. The analogy in my mind I always keep going back to is like when you are sick and you go to the doctor and you say, I don't feel well, she doesn't take out a textbook of a human body and try to theorize about your body, right? She takes measurements, like she takes out a stethoscope, she like understands your temperature and your pulse and listens to you breathe, right? So this is very similar. We now have network and disk space are now cheap enough that it's practical to measure a tremendous amount of what a system's actually doing, and then afterwards trying to like make some sense out of it. Anyway, that's my whole theoretical rant about that, but yeah. Other questions, thoughts? Were there any things that I brushed over that someone would like for me to talk a little bit more about?
Something you mentioned piqued my interest. You said something around like be prepared to open pull requests because this is a growing community for, I think a lot of folks here are, they're working with teams or they're adopting tools. So maybe they're not certainly looking for opening pull requests just yet. So like, what's your experience been, right? I know, because I know you're like in the, you're interested in that, but like for a regular team adopting, like, ought they really expect it, or is that like more of an edge case?
I think that's probably more of an edge case. I mean, I think what I would say is that like you should be aware that there can be like you might find a new issue, right? It's not, there's a lot of stuff being built quickly. It's done pretty well, and again, like it's being used at very large companies, so right, like a lot of the stuff I sort of feel like in terms of evaluating risk, you can be like, well, if it's good enough for GitHub, it's probably good enough for us. But you want to be honest about like the biggest thing is really not that, like I think a lot of the really hard stuff at the core of the OpenTelemetry libraries has been done. In my experience in Ruby, like the whole like setting it up and the processing and the exporting, like I've mostly not touched that. Like that's the really critical part of the pipeline, right? And you create a bug there, you can actually cause a lot of issues. By the time I started contributing about a year ago, most of that stuff was already done, right? And then a lot of the filling out was the instrumentation, because you can imagine there's like a list of 40 libraries. It's like, hey, Francis, take this one. I'm like, yeah, sure, I'll instrument this thing, right? And then, so I wrote the Redis instrumentation, right, which I think is working just fine. And there's a couple of changes we had to make, right? But as you can imagine, right, like the pieces get filled in. There's a lot of surface area, right? Is it possible that like, Faraday has this one set of options that almost nobody uses, that your app uses, and that if you use that plus the instrumentation library, that you'll find some funny bug? Maybe it's possible, right? One hopes that in that scenario it can be patched pretty quickly. My experience, by the way, is that the Faraday stuff was not that hard. Like the instrumentations are not that hard. I don't know though. I'm not sure if that's just me though. I was in OpenTelemetry for a while. But I think like the core is fine, right? If you're like, oh, this library is giving us trouble, you just don't use that library for a little while. You check in on it. Maybe someone patches it in a month.
Cool, thank you.
Other questions or thoughts?
Just going back, this seems to be like a tool to start decoupling like the measurement and the storage. Because I know we're like on Datadog for our app, but I can't imagine moving off of Datadog. Like you were just saying earlier, like your current company's on one company and like, hey, we're gonna switch.
Yeah. And
then, but actually setting up the OpenTelemetry is pretty smart, because later it sounds like down the road you can even switch from, another vendor to another vendor too, or even start self-hosting too.
Yeah, no, that's a huge part of the goal. Absolutely, right? Like, because, like if you do any real instrumentation of an app, you sort of like, you touch, you have like 30 different places in the app that you like had to instrument some custom thing. And the idea of like tearing that out to switch to a vendor is so like painful that you're just like never going to do it, right? OpenTelemetry offers sort of a way out of it. Another thing that's worth noting, which I hadn't talked about before, is that so typically in production, what you do is you'll instrument your app with OpenTelemetry and you point it at a collector, and that collector goes to your vendor. Maybe that's Datadog, right? That collector can send data to multiple places. So you could actually configure your collector to say, oh, I'm sending to Datadog and I'm sending to Honeycomb. Right? So you could send data to two places, which you don't want to do for that long. It's expensive, but you can sort of evaluate and compare and say like, well, are there any gaps? We're evaluating the second vendor. Are there any gaps? If not, you just change the configuration. You don't even have to deploy changes to your application at that point. It's just sort of like a piece of the infrastructure that you're setting up. The collector is, I've been working with it a little bit. It's pretty easy to set up. It scales out as a bunch of different cool options. It's written in Go, but you never have to write Go. It's just like you configure it and you start it, install it from an RPM package or whatever.
Yeah, I totally actually. One thing I really hate about Datadog is like I want to do some certain things, but it's like, oh, you only get 1 month or something of logs, but anything past like 2 weeks is like garbage on there.
Yeah. Well, and a lot of it also, like, there's the ability to query it, but then it's also like, the ability to store it, but then it's also like, well, what's the querying look like, right? Like, I think a lot of the challenge, and so there's been a lot of product competition in the last like 5-10 years of just like, oh, it's actually very similar data, but we give you like all these better ways to discover the thing, right? Because like everyone's been in, it's really common to get in some production incident and you're like, I know the data is in here, I can't come up with a query, right? Like, like I have this question, I cannot answer it. The data is in there some way, but the shape is all wrong. The query language is getting in my way. Yeah, so that's another thing to be able to sort of say like, oh, you know what, we like this vendor more.
Or you can just sign up for a whole bunch of free ones all at once and just.
Yeah, I mean, depending on how much data you've got, yeah, for sure. You can sort of compare and contrast.
That's the CTO maneuver right there.
Oh, cute kid.
Anything to help me measure this? Need to. It's a handful, especially now.
I have no expertise. I have no expertise in that area, Andrew. Any other questions or?
Oh, you just go back to that list you had.
Oh yeah, sure. All right. Hold on. This list?
Yeah. Oh, I was gonna ask. I was gonna ask, like, hey, what's the AWS version of this open source service? But you said it's what, probably X-Ray?
X-Ray, yeah. And I think like I haven't used X-Ray. I don't know that much about the specifics of it, but they want to sort of have their own version. But incidentally, of course, like, open protocols being what they are, you can have your app run in AWS. You don't have to use X-Ray. You can send your data to Elastic or Honeycomb or whatnot. There are, and because OpenTelemetry is emerging as a standard, there's a lot of different components. I'll give you an example. If you run, I helped this client, some of them run Lambdas with Node, and actually there's like AWS has like, because they have their own OpenTelemetry team. So AWS has like an additional, like a Lambda layer, which then the whole idea is that you add it to your existing Lambda, you kind of get this auto configuration out of the box, and it actually comes with its own collector, which is a pretty cool idea, because then like, and that's the OpenTelemetry collector, a very small version of it shipped inside of this Lambda, right? So if your Lambdas spin up from 1 to 1,000 in a couple of, in an hour or something like that, right? You're going to generate a ton of like data, and you're not going to actually be able to get it down the pipe all the way, right? So the fact that each Lambda layer comes with its own collector means that like the Lambdas can sort of like stay alive for as long as it takes for the collectors to flush out all their data, and then they shut down. So this is the kind of stuff that you get once you start standardizing interfaces, right? Like, oh, AWS didn't invent OpenTelemetry or the collector, but they're like, oh, we can use this with our thing and stuff.
Actually, you brought up the AWS Lambdas. So now it sounds like not only, APIs that are you kind of under your control, but you can start doing telemetry across like APIs that are your own, plus whatever serverless or whatever new fandangle thing too.
Yeah, and people also do instrumentation in mobile apps and like JavaScript SPAs, React, Angular, or whatever. That's also a thing. I'm currently actually helping them with some JavaScript SPA setup thing, which has taken longer than I'd like. But yeah, I mean, obviously, like we've been talking about Rails APIs because that's like I think the most obvious use case to our group. But it's really just like any any piece of software, if it's worth it for you to instrument it and sort of wire it up. Okay. Sounds like we're out of questions. Thank you all for listening.
Thank you, Francis. Thank you for cool topic.
My pleasure.
Yeah, thanks again. Tiny, we're starting like a new app, so it's just kind of nice, good timing to be like, hey, let's start incorporating this too. Clap, clap, clap. My hands are full.
You have to have your little guy clap.